Hello, I hope everyone is doing well. So in this video, I will be talking about the zeroth law of thermodynamics and a bit of the introduction with temperature and some terminology in regards to some basic thermodynamics. Okay, so the basic law of the zeroth law of thermodynamics is if system A is in thermal equilibrium to B, and system C is in thermal equilibrium to B, then it must be that A is in thermal equilibrium to C. Now this is pretty straightforward. I would say it sounds it sounds like a logical conclusion. If A is B and B is C, then A is equal to C, and in very much of the word, it is that. But this gives a really interesting concept within thermodynamics in general. And here's like a little demonstration about that as well. Since pictures are always fun, that all these systems must be in thermal equilibrium to each other, as long as they are in thermal contact, that is. So that would mean that maybe they share a wall of which only heat can transfer, or temperature, which would be through conduction, so on and so forth. But what would this mean? Well, this means that if two objects are the same temp, therefore TA is equal to temperature B, so system A is equal to system B in temperature, then there is no heat flow. No heat flow at all. So this is, like, I know I mentioned briefly, this should be like self-evident, but this brings us to a pretty profound concept within the physics of our universe, in that there is here I'm going to mark this out, there's a universal unit, I spelled that wrong, oops, there is a universal temperature scale. So this would mean that regardless of like material or etc., if there is 20 degrees Celsius, like if object A is 30 degrees Celsius and object C is 30 degrees Celsius, we know that they are the same temperature. And not only are they the same temperature, but if there is an object B that is 30 degrees Celsius, we know that these are the same units, they mean the same thing. The atoms are moving in the same amount in a way as each other, which, going further, is it makes things a lot easier. So that way we don't have like a different temperature for, a different temperature for metal, or there's a different temperature for sand, and there's a different temperature for, milk, just anything. It means that if this thing is 30 degrees Celsius and object B is 30 degrees Celsius, you put them together, there's going to be no heat flow. There's going to be, the temperature is going to be the same. Moving further in regards to this case of temperature and heating in general, does heat or does temperature, like the process of energy transfer, does it go from cold to hot, or does it go from hot to cold? Well, hotter items will lose energy and colder items will gain energy. So hotter and colder. So essentially, heat goes from hot to cold. So in terms of the thermal equilibrium, if TA is greater than TB, then that means the heat is going to flow in this direction in a way. Because temperature A is going to be hotter, temperature B is colder. Temperature A, or object A, I should say, or I should say this system A, system B, in terms of the heat, quote unquote, the heat system A is going to lose energy, system B is going to gain energy. But we talked a bit about thermal equilibrium, but what does that exactly mean? Because this is going to be a concept that kind of comes up quite a bit. Well, thermal equilibrium means that a system has settled down to where its macro properties are constant in time. So its macro properties are constant in t for time. So this would mean that in like a micro scale within individual like particles, there could be a bit of action. However, there is no discernible part in a macro scale. And of course, as we talked about before in the first video, thermodynamics is going to look more so at the macro, statistical mechanics will look more so at the micro, and then we will get to that and talk more about it. Anyhow, some useful terminology that will be a bit important as we go further. So, what is a system? We were talking about system A, system B, system C. What is that exactly? Well, a system is a body of matter, or a collection of like objects grouped together. So of matter and or potentially even radiation, I think as well. And then the concept of the environment is just essentially outside of the system. So we will talk about how the environment does work on the system does work on the environment, within the first law, actually, of thermodynamics. So the next law. And we also want to talk about this term adiabatic. What does adiabatic mean? Let's just say we have some type of wall. Essentially, no heat can transfer. So there is no heat transfer, which means that there is no loss or gain at all. This is not common in nature. Closed systems in general are not very common in nature, but this is a term that will be used quite often to better understand in like within thermodynamics, and we're going to talk about it a bit as we move further up the chain and then potentially move from adiabatic systems and then beyond. Anyhow, that is all. So thank you so much. I hope everyone is having a wonderful day. Please let me know if I made any mistakes, and